Thumbs up if you can hear me. Cool. So I guess you're the sort of people that get kicked out of nightclubs when the lights come on, because you're here right at the end, and I just want to say that I appreciate you staying. As usual, I was concerned that nobody would come to my talk, and particularly with this being the last session of the day, I was doubly worried about that today, so thanks for sticking around. I'm going to talk to you a little bit about some of the challenges that you might encounter when putting apps into production that are built on top of large language models. And this is a kind of weird thing to say, but I've been working with agentic systems development for the last 10 months roughly, and I'm probably an expert in the field because this is still new, all right? This is still pretty novel, and I bet there are very few people in this room that have got apps in prod that use the models, the APIs provided by large language model providers. Is anybody in that situation? Does anybody have a production application that they're using that depends on an API provided by OpenAI or Anthropic? So in a room of, I don't know, 90 people, we've got 3 that are doing something meaningful with this technology. So I guess I could be an expert having a year's worth of experience with this particular technology, but the other thing that should reinforce to you all is this is still new, and there's a lot of lessons still being learned about what it means to run production apps on top of this new type of infrastructure, this new non-deterministic application platform that we're trying to build on. So a year with LLMs, seriously a year with LLMs, but before that I had a couple of years with data infrastructure companies, and before that I was at Amazon Web Services for quite a while, working with startup customers and working with developers around the world to help them use AWS. And of course, I don't usually have GIFs in my presentations because I hate GIFs. Right, what is Griptape? So there's been a lot of quite salesy presentations at this event. I've sat through a few of them. Just want to reassure you that I'm not selling anything to you unless you're working for a video effects studio like DreamWorks or Universal Pictures or a major video games studio. We're not trying to sell to you, okay? So Griptape, our product, is actually a generative AI tool for creative professionals that want to use cutting-edge generative models for image and video manipulation. So if you're creating advertising creative, you're working on feature films, you're doing asset creation for video games, then we've got a product that is relevant to you, which is a visual canvas for building workflows for image creation, image enhancement, video creation, and video enhancement. But we've built a lot of stuff underneath that, which were really prerequisites for the product that we had in mind when we started the company 2.5 years ago. And the first thing that we built was an open source agentic framework called the Griptape framework. It's Apache 2.0 licensed. It's a little bit like LangChain, but we're not seeking to monetize that. It's still there on GitHub. You can download it. You can use it in accordance with the license. And it's pretty complete, okay? And then on top of that, we built a cloud platform, which is the substrate that we use for our creative generative AI tooling product. I'm really going to be talking to you today more about some of the stuff that I learned in building on our framework and contributing to the development of that framework. And I guess the first question to answer is, why did we build that at all, okay? And what is so hard about building LLM-powered applications? Why is it that it's difficult to get predictable results? Why is it that behavior of applications that are built using some of the APIs that are provided by LLM model providers is quite unpredictable, okay? And the main reason for that, I think, is this, okay? And there's another question you could pose here. What is ChatGPT? When you use ChatGPT, what are you actually interacting with? Are you interacting with a language model? Are you interacting with a language model and a collection of tools and enhancements? Are you interacting with a language model with a collection of tools and enhancements and sophisticated pre- and post-processing for everything that goes in and out of the model? Does anyone know? And the reason you don't know is because it's a black box, right? It's provided by OpenAI, by a provider, and they're actually, I wouldn't go as far as secretive, but they're quite cagey about how ChatGPT actually works, right? And because they're cagey about how it actually works, it's pretty unpredictable, okay? You can get unusual results. You can get results that vary from day-to-day, model-to-model, even instances of the same prompt in quick succession will actually give you results that can vary quite spectacularly. And I guess the question there is, who thinks it's a good idea to build a production application on something where two invocations of the same API can give quite different results? Does anybody think that's a good idea? No. So if you're not going to be using chat or not going to be only using chat, what API do you want to build against? Do you want to build against a model provider's specific API, so like an Anthropic API, an OpenAI API? Or what if you need to combine models, use local models and use cloud models in combination with one another, or even switch out models for cost efficiency or performance efficiency reasons? Don't you want to have some level of abstraction that allows you to mix and match different models or combinations of model inside one application? I would say yes, okay? So that is a really good answer to the generic question, why should you use a framework if you're building apps that use large language models? So my first piece of guidance is not directly on the model provider's APIs, always through a framework. Could be ours, could be LangChain, could be the ones that AWS, Microsoft, and Google have released over the course of the last year. But I would always say, introduce a framework. It will give you portability, options for model choice, and it will solve some of the other problems that I'm going to talk about in a couple of minutes as well. So, what about math? Anybody done any of these experiments? You know? And we all know fundamentally the issue here is that large language models are non-deterministic systems. They are, in essence, sequence predictors. They have no concept of mathematics. All they have is token prediction, sequence prediction in tokens, and they will get things wrong pretty much all the time. And they'll get things wrong by varying degrees depending on which kind of model you'll use. And the other thing is, until quite recently, we haven't actually understood what's happening inside a language model when it gives an answer. Now, there's some excellent research that came out recently from Anthropic where they were doing kind of observability and introspection inside the model when certain prompts were given, actually looking at what I'd say like thought pathways or synapses were being fired inside the model in response to certain types of questions, and being introspective about how the models gave responses back to the user. And they found out that maths inside large language models is kind of an interesting concept. Two things happen at once in their research, which is there's a sort of approximation of the general answer, and then some calculation work, in quotes, some sequence prediction work, in quotes, to try and work out what the last couple of numbers are on the answer. So, and then at the end, those two thought pathways are sort of merged together to give you a prediction about what the answer to your maths question is. So given that research and how the models work internally, it's not surprising that they're pretty crap at this kind of stuff, right? And also, LLMs, I mentioned this word already, they're non-deterministic, meaning that the same question might actually get different results the second time you ask it. So they're very challenged when it comes to giving precise answers to mathematical questions. We need a solution for that. The second thing that we need a solution to is that by itself, so without some of the extra stuff that we all suspect ChatGPT might be adding to their application experience, a model intrinsically has zero knowledge of the outside world, okay? And that goes as far as not knowing what today's date is, and not being able to answer simple questions that a child could find by searching the internet using Google. A model by itself simply cannot do these things. So to give the ability to collect current information about the real world, we have to provide additional information to the model, additional context, to enable it to know these things so it can give us meaningful answers to some of the questions we might ask. So, the Super Bowl problem, as it's called, to answer that question, we actually need two bits of information, right? The question was, who won the most recent? So first of all, the model needs to understand what the most recent means. And then secondly, it needs to be able to fetch fresh information so that it can provide a meaningful and accurate answer to that question. And by itself, a language model cannot do either of those things. Okay, so how we might solve that, get today's date, use that as a reference date, and then figure out who won the game. In this particular example, it's a little bit small, but I'm using Llama, so an open source model here. I'm equipping that model with a tool that allows it to read the system date from the system where the application that's calling the model is running. And then I'm also equipping that same system with a tool that allows it to go out and search the web, search the internet, and get up-to-the-date contextual information about the question that I'm asking. And by running that piece of code equipped with the model, I can answer that question in a meaningful and accurate way. So if we're simply using a model or simply using a chat response endpoint that's provided by a model provider, we're going to have to give our application more tools in order for it to be able to work effectively with up-to-the-minute context and with public information sources. Okay? You can solve the math problem in the same way. You can give your application a tool that can be used to perform basic mathematical calculations, and then the model response will be able to invoke that tool, and you'll be able to get accurate and correct responses to math questions that you might ask via your application. And of course, this is what's happening inside ChatGPT. ChatGPT is now actually very good at math, and I can tell you that isn't coming from any large language model. It's coming from something else that is added inside the application that you're experiencing, right? And you can do exactly the same thing in your own apps in order to get the similar capabilities. So, what about knowledge of the external world? I mentioned tools there, tools for date time, tools for searching the web, and you can have tools for all kinds of things. The modern way that we're solving this problem is with something called Model Context Protocol, or MCP. You've probably heard about it from quite a few speakers over the last couple of days. But actually there was something before that in OpenAI's API toolkit called tools, or function invocation. And we've had this for about 18 months, roughly, from OpenAI. And then Anthropic came forward with the MCP standard about 6 to 9 months ago, I think. And that added something really interesting. It provided standardization across different model providers. So everybody that's creating agentic frameworks, pretty much everybody that's creating tooling around LLMs, is standardized on MCP. You can use it in an agent. You can use it in an interactive tool like Claude Desktop. You can use it inside Cursor. You can use it in all kinds of software applications that need to interact with LLMs. And the most powerful capability, really I'd say there are two. The first is capability discovery. So with Model Context Protocol, when you initially connect to an MCP server, as they're called, the language model will make a query of the MCP server, and it will discover capabilities that are available to it through that MCP server. So this offers a distributed mechanism where you write the capabilities of the MCP components into the servers that provide those capabilities, and the language model will discover them automatically as it connects to different MCPs. Very, very helpful. The second thing is you can have a distributed model. So you can either run these MCP servers on the system where your agent or application is running, and that's what's happening if you use the standard I/O connectivity to an MCP server, or you can connect to them over a network using, this is called server-sent events over HTTP, and that allows you to break your MCP servers off, centralize them, auto-scale them, have large farms of computing capacity, and also place them next to data sources that they might interact with. So it's a very powerful construct for enabling applications built on LLMs to interact with other systems or even to interact with the real world. Here's an example. Again, pretty small, and I'm going to break the cameraman's advice and just step over here a little. This particular agent has got 3 MCP servers connected to it. Something called Graffiti. This is really powerful. This is graph-based memory for agents or LLM-powered apps connected via MCP. So it allows an agent or LLM-powered application to store episodes of memory, to establish relationships between entities, and then to recall that memory, and also to add to it incrementally as the agent performs more operations. So take Cursor, for example. If you're doing coding supported by an agent, this Graffiti MCP server would allow your agent to develop long-term memory about your interactions with the agent over the course of a multi-session, multi-day, multi-week, or even a multi-year project where you're refining requirements and developing more interactions with the coding agent. That will be stored in the graph memory and made available for subsequent interactions via your cursor session. It's super, super powerful. But you can also use it more generally in applications, and I'll show you an example in a second in a legal application where we're going to use graph memory to load information about a complex legal case. Okay, so you can use it on a general purpose basis for long-term evolving memories of interactions with your application or agent. Second thing we have is a bit more simple. This just allows the MCP server to access a file system. And then this allows us to interpret PDFs. So we can read the contents of a PDF file, convert that into a format that is safe for interaction with the language model. So it's stripping out the encoding that's present in the PDF and giving us Markdown, which is something that a language model can work with really effectively and really efficiently. So with this agent, I can load in information about a legal case. And I've taken here an employment law case from the UK. It's like a 100-page long judgment with about a 50-page supplementary judgment related to remedy, so pretty complicated. I give the prompt to the agent, read the files, load all identified facts in those files into memory, and I end up with a graph that looks like this, pretty complex. So each node is a fact or an entity within the case that's been pulled out by the agent autonomously. And from there, I can then ask questions. What was the ruling on the preparation time order? What factors were considered material? What was the preparation time award? And I get very precise and accurate responses back from the long-term memory without recourse to the PDFs. And I can load a huge amount of data in through this mechanism autonomously. And actually, when it comes to retrieval, it's like a graph RAG system. So it's using both semantic search and vector search concurrently on the graph to pull back facts and then traversing the graph to find relationships from the nodes that have been returned. So you get very effective memory response to even very complex queries using that type of technique. There's a lot of power there. And that is a standalone agent, a single agent just doing that one task. You often hear about systems. So agentic systems, you've probably heard this already. The best mental model for agentic systems is to think about a team. So if it was breaking down this task or outcome that I'm trying to drive with my application, what do I need in terms of goals, roles, and skills in order to achieve that outcome? A very common use case would be like research, summarization, and report writing, where you'd have research agents, summarization agents, and report writing agents, give them different system prompts, enable them to interact with each other, actually by usually providing them to a fourth agent, an orchestration agent, as a set of tools. And then that orchestration agent will invoke those sub-agents for different parts of the workflow. You can do the same thing. I built a agentic hotel management demo app for customer service, maintenance, housekeeping, room service, reservations inside a hotel. Worked really well, but you've really got to stretch the decomposition in response to testing. So one thing I found was my reservations agent was equipped with date time tools, but they really struggled to figure out whether or not things were in the future or not, which is kind of important for reservations. So I had to create another agent whose job was simply to determine whether a date was in the future or the past. So what you'll find with these multi-agent systems is non-deterministic. Testing will reveal situations where you have to break or stretch your mental model a little bit in order to get them working, and you should be open to that. So yes, start with the analog of a team, but just remember that some of your team members might need very, very specific instructions. It's not that different to the real world in that sense. And then the other important takeaway on agentic systems is, well, the clue's in the name, right? What is agentic derived from? It's derived from agency, which means operating autonomously under your own control, right? And when you hand over control and responsibility to one of those orchestration agents, you're not deciding how many times the different sub-agents get invoked, okay? So I would say that observability is kind of step one when building agentic systems. And observability for one critically important reason, which is cost control, okay? You can burn through a lot of tokens from your LLM providers if you don't observe your agents and understand what is driving token consumption. you can end up with annoyed people in your finance department, or a very annoyed credit card provider if you're using your own credit card to pay your own OpenAI bills. So I would say the first thing you should do before embarking any sort of significant agentic project that uses multi-agents is to build an observability system and make sure that your agentic code is thoroughly wrapped with observability tracers, so that you're collecting observability data, token count metrics and the like from your agents, even before you put them into production. So you can understand what kind of costs you're driving with your test cases. Really, really important. This is Honeycomb, by the way, honeycomb.io, which has excellent capabilities for gathering metrics from LLM-based applications. And then I guess the last thing is, how do you connect this to your existing systems? There's actually a lot of ways. So, there are agentic tools out there that you can use. I already talked about Cursor. It's kind of natural to use in a coding environment. There's a couple of really awesome agentic browsers that are out there. One called Comet from Perplexity. Another one called Dia from the browser company, the people that made Arc browser, if you're familiar with that. They're really cool. You can do things like cut and paste, or rather copy or highlight sections of a web page and give simple instructions like add this to my calendar, and it will operate like an agentic browser, grab information from your browser context, and then interact with your Google Calendar or other calendars using agentic techniques. But that's kind of all stuff which requires a human being to interact with it, right? And I think a more common use case is autonomous agentic systems. And I would say the easiest way to get started with that is something like Zapier or NAN, where you can connect events in your business systems or even in your personal systems directly to agent invocation. And what I have here is an email summarization agent. So I don't read my own email anymore now. Whenever I get an email, I have an agent that reads the email for me, and it pulls out key facts like who's it from, are there any dates or deadlines, do I need to take any action based on the email, do I even need to respond to it? And it sends me all that information in a Slack message so that I don't actually have to go to my email box unless that message is pertinent, it's got some sort of time deadline, and maybe I need to respond to it. But I have those questions answered for me autonomously by an agent that runs in line whenever I receive an email. So having one of these integration tools is just a cool way to get started with small-scale experiments, either with your own stuff or with safe systems inside your own business. Yeah, so to do that, we equip our simple agent with a few rules. And this is like as basic as it gets. There's a rule here which says, clearly state if there are dates or deadlines mentioned in the email. So this is loaded into the system prompt. This is how we define the basic behaviors and outcomes that we want our agent to achieve. It's super, super simple to get started. Okay. And then the last part is integrating with private data. Again, we've heard quite a lot about this over the course of the last couple of days after I submitted my slides. So I'm not going to go to town on RAG. I think actually I share a viewpoint with a speaker that I saw earlier today, which is that I think that MCP and tools is going to replace or displace a lot of the stuff that we used to do with RAG, okay? And the main reason for that is that populating a system for retrieval augmented generation is largely a batch asynchronous process, right? So you need steps. You need basically to do this stuff over here. Collect your documents in a location. You need to split or chunk your documents semantically into a format where the chunks that you're going to retrieve make sense for your particular use case. You need to generate embeddings from those chunks that you've created using a separate embeddings model. And then you need to store all that stuff in a vector store. Which means that whatever you do, you're always going to be a little bit behind current with the contents of your vector store. Unless you've got some sophisticated and probably expensive streaming data pipeline that chunks and vectorizes data as it arrives in your enterprise, as it arrives in your system, you're going to have an issue with up-to-dateness of your private data. So I would caution against having a heavy dependency on RAG unless you've got a lot of resources and your use case is particularly non-time critical in most cases, okay? Once you've done that, we're going to augment our response by making a vector search, looking for context which is relevant to the query that's been made, ideally re-ranking the results that we get back. So this is measuring the relatedness of the query results that I get from the vector store against the original question that I asked. And then we create our augmented prompt, and then we generate our LLM response, and that's how you get RAG working in practice. Okay, so for a typical query like, what is the capital of Paris, for example, I might get back results like the Eiffel Tower, Paris, Frankfurt, and San Francisco, and then the re-ranker would flip those results and would put Paris in position 1, probably San Francisco, and the other city that I mentioned in positions 2 and 3, and then the Eiffel Tower in 4, because it's relatedness, right? And that's what the re-ranking phase is. This is really important if you want to get good results. It's the phase that you should definitely not skip when building a RAG application. If you do want to experiment with RAG, and one of the other issues here, by the way, is privacy. So quite often, when we're building applications that use up-to-the-minute and private data, one of the concerns that we've got is we don't actually want to send that data to an external API endpoint, okay? Because it's, by definition, private data. It's not been available to a model when it's being trained. And some of the embedding services that we might typically use are actually endpoints. So you use a embedding API from Cohere, for example, which is a popular one. Every one of your text chunks needs to be sent off to Cohere. And yes, they are complying with data privacy and regulatory requirements, but some organizations still would have concerns about that. So here I've got a worked example of a fully local RAG system using a local re-ranker. So if you're interested in like how to build this using air-gap systems, that might be of interest for you. And then lastly, if you do want to take a look at the framework, remember this is open source. We're not seeking to monetize this framework. It's an alternative to frameworks like LangChain. You can find it over here on our GitHub. And I think that is pretty much all we have time for, unless you have questions. Thank you. And thanks for staying till the end. I know it's been a pretty long 2 days, so thank you. Thanks so much.